Hey everyone, thanks for joining. Hey Ravi, I think among the in the topics I mentioned one of them, the host interface trap PR as the first topic because the other one was raised like kind of after cutoff, so I want
Yes.
to do
Yeah.
that
Yeah.
later.
Sure. That makes sense.
Yeah,
Yes.
let's close the other PRs
Yeah.
and then if we have time we
Yeah.
can get.
We can.
Yeah,
Yeah. I can get started if Jay. Right. I think only Jay and I need to discuss the other PR. So maybe I'll discuss.
go
Shall I
ahead,
get
please go
started?
ahead.
Yeah. Okay. Hi, Jay. Jay. I think your question is valid, but I just let me explain from the sonic background. Right. What's happening? Uh, just let me do a recap of what we are trying to do. Okay. So this is what's happening in Sonic today. Let's say on an interface, I assign an IP address in Sonic, right? When I assign an IP address to an interface, so two routes get added in Sonic. Okay. One is the /32 route, which is what we call the IP to me route, packets that are destined to this interface. These need to be handed over to the protocol layers, and that we call as IP to me route. And for that, what Sonic does is, this is as per SI definition. Okay, as per SI definition, what needs to be done is, if you look at this, right, /32 route is added, and in this case, the packet action will be forward, and the next stop will point to the CPU port. So this what is the Sonic definition. So SI definition. I took a capture of what is defined in SI. Okay. Let me go right. So this is the definition of SI route, how to use a route entry to achieve this IP to me. To achieving the IP to me, the next stop should be used. The next stop will be used with the next stop is the CPU port. Okay. And similarly, when we are going to create a route for reachable routes, okay, for in that case, what we do is we fill the router interface as the next stop. Okay. Jay, so far clear, right, Jay?
Yeah, I'm rebuilding my cache. Keep on going. Yeah.
Yeah. Okay. So this is what is actually going to happen. I thought one second, I update the comment. Yeah. Okay. So basically, the two routes are getting created, Jay. Okay. And what?
Ravi, can you go to my comments?
Yeah. I'll explain to you, right? I'll explain to you the
I
comment.
just want to see what comment I made.
I'll explain to this. So this is Jay. So what is happening is your comment is valid, and I'll explain to you what it is. So right now, in SI definition is these routes will be created with packet action forward, and the next stop would say, hey, either it will point to the CPU port or the next stop would point to the route interface. Okay. And what has SI done is for the IP to me packets, when the next stop is pointing to the CPU port, there is a global default trap defined called IP to me, with which the NOS can control to which queue all the IP to me packets should come. Okay. But there is no such a trap defined for packets that hit the router interface routes. Okay. So what we proposed is in the last community, Marian, what we all discussed, right? We added another trap type for this neighbor miss entries. We created another trap type for neighbor miss entries. So this was the proposal. And Jay, your comment was, why not use user-defined traps to achieve this purpose? Okay, your comment was, why not achieve the same thing using user-defined traps? Let me.
Yeah, I went and looked at our implementation, and I saw that there was already this one. There's a host type user-defined trap type neighbor, and this does exactly same what you are proposing.
Jay, as per SI, right? This means the NOS, it cannot work with Sonic today because user-defined trap is applicable only when the route's action is trap or log. Let me quickly show this to you, right?
It's for neighbor miss as well.
No, let me show you. Okay. Today, if you look at it, all the routes are getting created with the packet action is forward. Okay. As per SAI spec, all the routes are getting created with the packet action as forward. Let me open this. So now the packet action is forward, and for us to use user-defined trap, right? If you want to use a user-defined trap, then the route's packet action should be one of trap or log actions. It cannot be a forward action. User-defined trap ID, this user traps, right? This trap is valid only if the packet action is a trap or log.
Ravi, I don't have the full, I lost all my context. All I was saying that today we do have this functionality which works, and even in Sonic, right? So my question was that why we need this. Today we have something which is working.
It's not
What is
working in Sonic, Jay. It's not just with us, right? We have seen customers reporting this issue. That's the reason, right? It's not working. It's not just our platform. In other platforms also, they have this issue, and they're been using some hard-coded values. And they're asking us to use hard-coded values. That's the reason we, instead of doing all this, we want to enhance SAI to work correctly. This is the logs I've taken from Sonic just right now. If you look at the timestamp, right? Just a few minutes back, I took the logs from Sonic to see what's happening, right?
So today, Sonic does not have a way to do IP to me to a specific queues for the.
It has for IP to me, Jay. It has for IP to me by this trap, right? But it doesn't have for neighbor miss.
For neighbor, so today in our open source Sonic, that functionality is not there.
It's not there.
And okay, so you're saying that it does not exist, and if it does not exist, then my question was, today I checked our implementation, our version of Sonic, and we use the UDF, right? The UDF trap.
Yeah.
That
Jay,
I think that was question was coming, why we can't use that.
That is because, right, Jay, if you look at this is a simple answer, right? UDF is the user defined trap you can associate with the route. Okay. And this route can be.
Yeah, no, what I did saw in the UDF, there was, this will waste a lot of time. Let's take it offline and we'll finish it today. Okay.
Okay.
Because I have to, just 1 second. I didn't realize that this is going to be on the call. UDF. Yeah, the UDF entry, right? Let me just see.
UDT, right, Jay? Just to be, UDT.
Just give me 1 second. Let me read my start trap. Just give me 1 second. Where are comments? Okay. So so we have a user-defined trap type neighbor, right? And it says generated by neighbor table entry hit with action trap log or by neighbor table miss. It says neighbor table miss. So if you see user-defined trap type neighbor, so it is in compliance with SAI spec. That's what I got confused with, because it clearly says so. Can you
Jay, go 1 second. I will just open that part.
Yeah, trap type neighbor, user-defined trap type neighbor. Here, right? Trap type neighbor. If you see the comments, it's generated by the neighbor table entry hit with action trap like or by neighbor table miss. It clearly says that.
Jay, that's a problem, right? So what, in general, any user-defined trap type, okay, it works only when you go attach it to this is a difference from the standard default traps, right? What we are trying to do is add standard default traps. Any user-defined trap by definition, right, they should be created and attached to an object. For example, just defining a user-defined trap type ACL doesn't mean any ACL trap packets will be controlled by this, right? You create an ACL, a trap of this type, a UDT of this type.
Yeah, that's okay. Why can't we create and assign it to the route object? That's what you needed, right?
This right, Jay, says a user-defined trap of type neighbor. Okay,
Correct.
that means you have to attach it to the neighbor object.
Correct. And what's wrong in that?
The whole point of this entry, right, Jay, is for cases. This entry is for cases where there's no, for example, this, right? In this case, there's no neighbor. We just have a route. The neighbor is not resolved. That's why these packets need to go to the CPU so that ARP or something can be triggered.
Yeah, that's what it says, neighbor miss, right?
Jay,
I mean,
neighbor.
See, there is a clear workflow using that which works today. And my question, I can publish that.
It doesn't honor, yeah, maybe that's true, but this doesn't honor the SI, right, Jay? Because you're saying you'll create a user-defined trap type of neighbor and attach it to a route entry.
So I'll show you that. I'll send a snippet of the code, but my single contention is that, this is a working flow, and it clearly says it is for neighbor table miss, right? It has a very clear comment. It is for neighbor table miss. Okay. I don't have full information that how it's implemented, but I can post that, and it works. And we have been using it for a long time.
It's not done Sonic and okay. And
yeah, I mean, we have our version of Sonic too, right?
Okay. So but my contention would be it's not SI complaint, because by definition, if you create a user-defined trap type, you can attach this trap type only to that particular object. For example, I can't create an FDB trap and attach it to a, let's say, ACL or a neighbor.
That point is valid. So let me find out today. I'll post it to a PR that what is the binding and exact workflow, right? And if you see a problem in that workflow, then I agree with you, right? But my only thing is that I sat with the engineering team, and it's we do a full granular, because all the control protocols which go on the neighbor miss, they need to have different queue, etc. So we do a full multicast, unicast, such and bump traffic, whichever go through the neighbor miss gets its own queues, etc. So we fully support it. And last thing I want is that another method. So let me publish that workflow. And if you still are able to convince me that yes, there is something wrong in that, right? Then we can.
Yeah, I'm just saying, when is the time for this?
I may add something. I think the main issue is that it requires defining a trap ID per route. So now you need extra metadata on a per route basis with that config model, rather than having a single default that can be used. For example,
no, you can have a single default user-defined trap. You don't have to use per route, Jason. It's no different.
But where would you attach that single user-defined trap?
See, that's what I said, that it's working, and I'll publish the workflow. I don't recall.
Yeah, because I think today, we support this almost exactly this proposal as an extension for some users, because there isn't like a way to define the default today. Like let's say you just put null on the route. Like, what's the default behavior? There should be some definition. I think it was a standard default.
Yeah.
What should happen?
No, we do have a default. We have to create a UDT during the system bring up for the neighbor miss. And then if there is any specific difference is needed for a given traffic, then we create a different UDT. But I don't have a exact workflow with me.
Just to add what Jason says, right? See, we can always use UDT to achieve all of this, right, Jay? That is when I want to say for each route, I want to have different behavior. Let's say for route interface 1, if I have a neighbor miss, send it to Q1. For route interface 2, send it to Q2. If you want to do all these differences, that workflow really makes sense. That's because it's a lot more work for the NOS to do, right? But for example, if you are taking the same example, IP2Me also I could have achieved using just UDTs. I don't need to have created a new trap type for IP2Me. All I could have done is created a new user-defined trap and attach it to all the routes.
No, I understand, Ravi. I'm not denying what you're saying. I'm not saying what you're saying proposing is not going to work. All I'm saying is that there is handling for neighbor miss in UDT, and that works, right? So why have a new one? And your contention is that actually it will not work. There is
No,
a binding problem.
it's
Yes.
that's one point of it. The other is, right, Jay, we want to give a proposal that is aligned with what is there for IP2Me. IP2Me and neighbor miss, right? Both let us give same workflow, makes it simple for the NOS.
Let me, I didn't got the feedback. I sent this PR and this PR workflow got shut down, right, as redundant. Let me discuss with the team that why it got shut down, right? Why they think that it's redundant. If there is a advantage, then I need to see the advantage, right? I mean, whatever you're saying, they say that it can be done by UDT. We really don't need to have another attribute.
But Jay, I think how it's being done by UDT, I think unless they say that, it doesn't make
Yeah,
sense.
I'll send it today. Don't worry about it.
Yeah. And what they are doing is
I will also question what you are saying, that the binding is not correct. If they are doing a funky thing in the binding or making some assumption, then that's not correct. Right?
Yeah. And one more thing, what we have to say is, right, give a workflow that's identical to what is host of IP2Me. We don't want NOS to do multiple things, right? One way for IP2Me and a completely different way for neighbor miss.
But there are two different flow paths, right? You can, why not?
It's all same, right? Because we are trying to, what NOS is typically interested is doing something at the NOS level, global level, not per riff or doing something, anything at the per riff or something, right? The intention is,
you have a different processing for IP2Me, and neighbor miss may have a different processing. It's just it's a level of, I mean, JSON is there, right? There was something long time I remember called as LPTS. I don't know if it still exists or not, right? Where so granular flow was there for the fabric chassis, right? For the neighbor miss, it's taken to a different multicast ID, fabric ID. I remember that.
Okay, yeah, I think I miss. I think what I said is right. Let's today also, even the IP2Me also, we can take to multiple same IP2Me on different routes. I get to go take it to different queues, right? Correct. I can start giving different treatment. Same thing we can do for neighbor miss. That is one proposal that is always there. On top of it, there is a way to globally control, which is the most common case, right? Globally control. Both workflows are there for IP2Me. So we want to give the same both workflows for neighbor miss as well.
Yeah, I got it, Ravi. Don't let's not waste time. I got your reasoning for it, right? Let me just I have to validate it, right?
I'm not sure why. When can we get this? Okay, let's see. When is the?
It got clearly declined from our engineering that this is a redundant flow which we are creating.
Jay, one more point, if you can hear me, is that the right usage for user-defined? Because right, that's I think that's a more deeper question, right? Is to do something which neighbor miss, which is standard, right? It always happens. Is user-defined trap the right mechanism to do it, or you want to do like the host trap for all like? I think that's also a question we need to think about.
So I think the way I see it, the reason this UDT neighbor trap got used for neighbor miss because there was no other mechanism. That's what I was told. And then I was told that comments clearly mention it, that this should be used for neighbor table miss. All right. So you are right. Right. This may not be the UDTs are special cases, right? But I have to run it by the team. Sorry, Ravi. I mean, I'm not holding it unnecessarily. And believe me, if I'm able to convince them that there is a issue in the it's not a complete workflow or a special workflow, because eventually they have to consume this as well, right? So.
Okay. Yeah. Okay, Jay. So let's see, right? If you can get it. I'm just trying to look at Tejaswini when she's doing the pull for 115.
Yeah, the plan was for tomorrow. Sorry, the plan was for tomorrow. But Jay, I think like I know you're checking if this workflow, there is an issue and works with the user-defined trap, but I think what we need to resolve here is that the approach the community wants to take, right? Or have something standard. So like, let's assume for a second your engineering team, what they come back does work. So at this point, I guess what we need to decide is that what we want to stay with or introduce this new
That is correct, right?
new entry. Yeah.
Right.
Yeah.
Right.
So maybe we could close on that.
Yeah, even that, see, I don't have the full data. And as I said, I'm gone out of cash on this. So my thinking is there is already if you just ask from the spec point of view, there is already a proposal. If it works, why introduce a new proposal, right? Are there any issues with that? And what I hear from Ravi, there is an issue of like for a miss, you need to have binding for the neighbor object, and for the /24, you don't have a neighbor object, and that's a valid point, right? If that's the case, then I think the argument of you reusing this or it's a hack, the way it's implemented, it does not. But let's say, and I have not looked at the code, there is a way to do that. Then I'm just going to publish that, right? There is a way to do that.
Jay, are you planning to publish this on the PR? Just
Yeah.
for curious.
Yeah,
Okay, thank you.
Okay, Jay, let's see, right? Maybe,
Yeah.
I'm not sure.
We'll close it, Ravi. Don't worry about it.
Okay, yeah. Okay, thanks,
Okay, yeah.
thanks, Jay.
So
Yeah,
if we can reach
Yeah.
a conclusion, by end of today, that would be helpful. Then we can push this.
Ravi is in India, so probably it's going to be his late night. So, but we'll figure it out. Don't worry, Ravi.
Yeah, sure.
Okay, yeah.
Not
Okay.
here to solve this for sure.
Oh, sure. That's fine. Yeah. Just want to. Okay, I think we can go to the next one. I think Nader's probably.
Yeah. Nader, you want to go ahead and share your screen?
Sure. So this was for the prefix compression tables. We had there's 3 items that I want to cover really fast or ask about. One was Ravi, you had requested that the entries have a priority on them, and I was wondering the reason for that, since this is an LPM table, and I feel like the features that are going to take advantage of this would be a feature that wants to take advantage of this longest prefix match.
Okay.
When would you need to have a non-longest prefix match have a higher priority?
Yeah. That's one way of looking at it. My thought is, right, see, the functionality is match a prefix, assign a metadata code, right? That is the functionality. And one such implementation would be to use an LPM under the covers. But I don't think we should call the functionality as use an LPM match. That was only my intent from start, right? I'm trying to think of it as it's something that matches on the prefix and assigns a metadata. How we match a prefix is up to the underlying implementation. It could use whatever mechanisms, right? It could use LPM table. It could use ACL, TCAM. It can do anything under the covers. But the functionality, the modeling inside should not assume that it should be an LPM table. That's what my intent was.
Okay, so let's say we go to the second example that you gave, where we're using ACL, or we're going to use something like ACL. You can already do that in ACL today. You can map a prefix to a meta in ACL. So if you're not using LPM specifically, ACL can do that today.
Yeah, but I wouldn't go that direction. And the reason is it may still be useful to define it via this API, even if the underlying implementation is a TCAM. But I think the more important thing is that there's no other logical way to assign a priority when dealing with prefixes than that the longest match is the higher priority. Like, you can implicitly think of in a TCAM implementation that the priority is the prefix length. So if you have prefix length 24, the priority should be 24. If the prefix length is 128, let's say it's IPv6, then the priority should be 128. Like, there's no logical priority definition other than prefix length when you're dealing with prefixes. So you would never match a wider or more generic prefix ahead of a smaller or a longer prefix length or a more specific prefix. And that kind of creates a problem in the sense of like, how do you define the default? Like, let's say we added a priority field here. The logical default and the thing that some implementations that are LPM based would only support would be that the priority is the prefix length. Like if the implementation of the hood is LPM, then that would be the only thing that implementation would support, would be priority equals prefix length, in which case you'd have to define that as the default. I don't think there's a good way inside to define a default that's variable like that. But also a TCAM implementation would have no reason to accept a different priority. Like there would be no reason that you would need to ask the user for the priority for this table. Like it should just always be longest prefix is the highest priority. And that can be like implicit. Like we could put in the MD file implicitly the priority is, or the priority of the entry will be the prefix length in the description. And that would, I'm wondering if that would cover the use case there.
Okay. Okay. Two questions, right, Jason. So one, what you're saying is, yeah, I'm yet to think of a use case where it is. Let me try to think aloud here, right? The use case of why in where I can use the priority. I just was looking at the model, the way it was modeled here, and what I see is the same LPM table, same compression table can be used for in a given ACL table for both source IP and dest IP. The way it's modeled, right? Neither
yes,
that's right.
Yes,
right?
you can
the
assign it to
same
both if you
compression
want.
table can be used for both source IP and dest IP. And now let's say a packet comes with 10.1.1.1 and its source IP is 10.1.1 and dest IP is 20.1.1, right? Now, I could have in the same prefix table one entry for 10.1.1/32, another entry for 20.1.1.1/32. Okay, since it's LPM, what's going to happen, right? Will both the things be assigned? What's going to happen?
Yeah, so what would happen in that case is if you wanted to use the same table definition for both the SIP and the DIP, you effectively would need to create two lookups, a SIP lookup and a DIP lookup into that table. That might require an implementation to replicate the table if it needs to, do them as two parallel lookups internally. I think we added some definition that you can make something SIP only or DIP only or a SIP and DIP option for that. Because you generate two metadatas. You would generate a SIP metadata and a DIP metadata as a result. So there wouldn't be like a priority contention between those because you're basically treating those as two independent compressions, a SIP compression and a DIP compression. Now, in implementation, decide to support only SIP to compression or only DIP compression or both. That's also an option. But that would be if you were doing both compressions, you're basically doing two lookups generating two independent results, and the ACL would be matching on those two independent results as the SIP field and the DIP field.
Okay, so in the day that's going to be two separate lookups. So you're saying the priority doesn't matter because each one will have a separate lookup. So in the first case, I'll do a lookup on the source IP. The second case, I can do another lookup on the dest IP. Either on the same table or two different, that's the implementation detail, but there are going to be two different lookups and each lookup will have a different hit.
Yes.
So you're not going to use priority.
Yeah, and then the ACL would have a field for the source code or the source prefix code and then the destination prefix code in the ACL. So you could, for example, compress 1,000 source IPs into one code and you can compress 1,000 dest IPs, for example, into one code. And then you could have a single ACL entry that matches the source code and the test code. Like that.
Yeah. So again,
I thought that you already put two different tables, right? You have a dest table and a source table.
I have the option to define in ACL there is the option, and when you create these tables in prefix compression itself, you can create it as a type. You can decide if it's a source one, destination, or both. Just both. Flexibility.
Right.
So you have the option to do the table type, which is
right. And Ravi, your contention is if it's type both, then how do you resolve whether you want to do
priority? Yeah, that was.
How do you want to? So I mean that, yeah, so that kind, if you have both, so then you want a resolution between two, then you should not create a table type both, right?
So for
I was
table
just
type
trying how to
both, I think the workflow
yeah.
is a little bit different than that, Jay. The workflow would be basically it allows an implementation that supports a single instance of the table to be looked up twice to be able to define it that way and create a single instance table that gets looked up twice. It would still generate two results and no priority contention between those. The intention isn't that it would be looked up twice or have a priority between a SIP and a DIP and produce a single result. I would still need to produce two results in this case, a SIP result and a
Yeah,
DIP.
but that's implementation detail. I mean, if there is an implementation which do not want to do a lookup on the same, for the memory bandwidth, then you can have just two different tables for SIP and DIP, right?
Yeah, exactly. That's exactly right. And those could be defined either as a SIP table and a DIP table from SCI, or it can be defined as a both table, and then the implementation replicates it once you've said it's defined as both.
Right, right.
Okay.
Yeah, I think that's flexible enough. On the Ravi, I still did not got your resolution point.
No, sir. I was just trying to see, shouldn't we let the user decide, give the flexibility to the user, and whichever platform supports the priority, the user can use it. The other platforms, we can always assume that it's an LPM, the longest prefix will be the higher priority. And wherever platforms give the flexibility to the user, let them break the tie the way the user wants it. So
the regular LPM lookup you are talking about?
When there's a conflict, right? When I use a table type both, okay, and let's say the table type both, and there's only one lookup that's going to happen. If there's a table type, the compression type is both, and let's say there's only one lookup that's going to happen, right? I was thinking that you need to give a priority to break the resolution.
So one lookup will give you one result, won't give you two results, right?
Yeah, and which is the one should take precedence, right? Let the user control that. Okay.
Yeah, I think that's so. And that's what I was just thinking when you were saying, if I have to implement, what if I have such a constraint, then I'll just create two different separate table types so that I get the SIP resolution, DIP resolution, and then let ACL run the prioritization, right?
ACL in this case would not, right, Jay, because
ACL has a match on the meta, right?
Match in the meta,
and that I can say that my SIP resolution meta is higher priority than DIP resolution meta.
Because I think you brought a more interesting question, right? What I was trying to think of is the way this is modeled, right? This pref compression table is bound to an ACL table rather than a set of ports. Just trying to think, right? Let's say I have port P1, P2, P3. I have a set of ports that are facing customer 1, another set of ports that are facing customer 2. And I want to say, for customer 1, I want to have different compression versus customer 2. Okay. So let's say, right, on port P1, I want to allow the range of addresses from 10.1 dot something, 20.1, some disparate, I have some 100 prefixes which I'll allow as a source IP. On port 2, I'll have another different set of prefixes that I'll allow. And in the end of the day, I want to use a single ACL table where I allow all the allowed packets and police it to the common rate. Okay. Jason, another what I'm saying is, right, the way this is modeled is this prefix compression table is bound to an ACL table rather than it being bound to a set of incoming ports or that way. And because of this, some of the things which we can't solve is, right, if I want to do compression based on an incoming port.
Yes, you're describing a use case where you would have different compressions for different ports. I don't think we've seen that use case. I don't think there's anything inherent in the prefix compression object that would prevent that in the future. Today the definition is that the ACL it's bound to the ACL because the ACL and the prefix compression information is basically coupled together. And from an implementation point of view, you don't necessarily want to burn more port attributes on a separate definition of which prefix table to use.
No, Jason, that should be doable, right? I mean, today you do a prefix compression. All you have to do is derive the VRF from the port and include the VRF in the compression key, right? You have to just extend this proposal with the VRF. No?
No.
Right, but what we found is the use case has been that this is more tightly bound to the contents of the ACL. For example, if a port has a different ACL, that ACL might use different sets of SIP and DIP addresses, and that the ACL itself would contain both the prefix compression, basically the prefix compression table to use, as well as the understanding of what the encoding is of the prefix compression result from that table.
No, I understand that. So I think what Ravi is saying is if there's a port binding of the prefixes, and that only is important if there are overlapping, all right? Otherwise, they're segregated namespaces, right? Right, Ravi?
Yeah, that's what. If it's overlapping, that's the question. Yes.
That's only when it becomes relevant. Then in that case, you have a VRF which is coming from the port, and the compression logic, what you have in the ACL table, Jason. So today you just take the SIP or the DIP to trigger the compression. You can create a tuple which is also, VRF ID. I'm just thinking if I have to implement, then what I will do. Is that not true?
Yeah, so however, it's the quote unquote, I think you're basically describing the VRF ID as a qualifier for a prefix lookup. So eternally possible implementation.
No, you can just use it for compression key. Create a meta using VRF plus concatenate or whatever you want to do. Right? I mean, you don't have to create
When you refer to VRF, do you refer to the VRF assigned to the packet when it comes in on the port, or a uniquely assigned VRF from the ACL?
No. Coming from the port, because that's where your overlapping address range will be there, right?
Right, but I think the prefixes that would appear in the compression table would be different than the prefixes that appear in the routing table. You're not necessarily want to, combine them into the same, VRF in the routing table. So you can think of this as, one way to think about this is creating a separate logical VRF that's just for the purpose of ACL compression, as a way of implementing it over an LPM. But you wouldn't want to mix these with your regular routing table.
Yeah, no, that's not what I was doing. I was just looking that you have a packet coming in with a SIP or DIP, and you trigger a compression on the incoming SIP or DIP. Is that correct or not?
Yes, you trigger a compression on the incoming SIP and or DIP.
And or DIP, right? Now, and if you have overlapping, to Ravi's point, overlapping address spaces, then all you have to do is, meaning you can have port 1, 10.1.1.1, right? And port 2, 10.1.1.1. In that case, you can disambiguate with port 1 if it's carrying VRF ID, let's say 10, port 2 is VRF ID 20. Then your common compression string becomes 20 plus 10.1.1.1. And it will give you a unique meta compared to port 2. But that's a orthogonal, that's a future we are talking. But Ravi, that should be doable. We can always enhance the compression table, right, to include another field.
No, I think what is blocking that, right? That's what I'll tell you. What is blocking that, Jason? What is precluding from what we want to do in the future is, Jason, if we can show the SI ACL table attributes you added, the SI ACL table attribute that says source prefix compression table.
Sure.
That just thanks, yeah. So not this one, the below. This is fine. This is good. These two attributes, right? So now what these two, the problem is in 1617 and 1631. So what they say is, I can assert a unique compression table with there can be only one compression table to compress the destination addresses for a given ACL table. So I cannot have a different compression table for ports 1 to 3 and then another compression table for ports 3, 4, and 5. I'm just trying to see, are these two attributes really needed? Can't we do away with these two attributes?
So what we've seen in the use case requests so far is that the prefix compression table to use is always bound with the ACL, meaning ACL, let's say you have ACL 1, you would use prefix compression table 1, and of course there might be a 1 prime, which is for the destination. And then for another ACL, which might be applied to some other ports, you might use a different prefix compression table. So logically, it made more sense to map the ACL table to use to the prefix compression table to use. Now, if in the future we see a use case to assign those independently per port, then we could consider adding a port attribute to assign the prefix compression table, and allow for a workflow that that came from the port, and then the ACL could leave this as being null and still allow for prefix compression. But today we haven't seen that use case, so it made more sense to have this as a mapping from the ACL rather than as more port attributes that you would need to assign, like to assign a separate ACL table or assign a separate prefix table on a per port basis, because that consumes probably what's a more precious resource in implementations, which is port attributes rather than a simple mapping from the ACL.
So Jason, I didn't still understand what do we achieve by these two attributes, right? I'm trying to understand what attributes.
Yeah, so basically what these attributes do is let's say a given port, or maybe the switch, maybe it could even be switch global, wants to do a lookup in ACL 1. There's an ACL called ACL 1 on system, and it wants to do a lookup on that. Now that ACL is using prefix compression, so it's going to have entries that are matching on bin codes within that ACL. Okay. Now that ACL will also be associated with a compression table, potentially it could be 1 or it could be 2, that basically describes how to take a list of prefixes and compress those into those bin codes. And I forget if we call it bin code, or I think we changed the name to metadata or something here. But yeah, basically take a list of prefixes and compress those into, for example, 1 value of that metadata code. And so allow for conservation of the ACL entries within that ACL. So that binding, that association between like what is the meaning of a compressed set of prefixes is kind of specific to that ACL. At least in the way it's envisioned here, that ACL defines maybe ID1 as being this set of 1,000 prefixes, and maybe ID2 as being this set of 500 prefixes, and ID3 as being this set of 400 prefixes, and so on. And especially if you're doing both lookups, that can create things like as much as 1,000,000 to 1 compression of how many TCAM entries you need. But that meaning of what those IDs mean is generally, at least in the design that I've seen, is kind of local to that specific ACL. It's not like a global meaning. And so these attributes are just saying, hey, this is the prefix compression table to use for this ACL.
Okay, Jason, just to make sure I understood what you're saying, you're envisioning an implementation where I would have multiple compression tables. Okay, for same source IP address, there'll be multiple compression table entries. Each compression table entry would give a different result. And at an ACL table level, I can choose which of these compression tables should be tied to a given ACL table.
Yes.
So that what it boils down to is you're envisioning to have multiple ACL multiple compression table entries. That's what you're saying, right? Multiple compression tables as such.
Yeah, you could have multiple. If you were doing multiple ACLs with compression, you could have multiple compression tables. Those ACLs could also share a compression table if you wanted them to. I mean, that's allowed, but that would require now is kind of a global assignment of these IDs, and I don't really envision that. I envision mostly like you're processing that one ACL, doing a compression processing on that one ACL, and so here's how you've decided to assign your IDs. And that can either come from the user through a CLI, like the user actually defines prefix groups and things, or it could come from some NOS algorithm that analyzes an ACL and decides how the prefix compression should happen. But either way, it's yeah, I envision being associated with that ACL, and then you go through prefix compression and the ACL lookup on that.
Okay, Jason, what you said is right. The case you're talking about is there'll be multiple such lookups going to happen, right? On a given packet, each compression table lookup is going to happen in parallel. And it means that we'll have to have multiple compression tables created for to support what you said just now. Okay. And the more common case would be,
yes, if you wish to allow a configuration with multiple ACL tables with compression. Keep in mind, it's not necessary to allow that configuration. That would be a kind of a more advanced use case. The API allows for it, but if you had just a single ACL table that's using compression, then you would only have one lookup per SIP for the SIP and one for the DIP. If you wanted to support multiple, that the implementation would have the flexibility to allow for that. But I wouldn't expect all implementations to necessarily support, there's going to be some constraint on how many lookups you can do in parallel, how many table lookups you can do, how much metadata you can carry. Any implementation will have some constraint there on what you can actually do, but the API would allow for it, yes.
Just last question, right? Let's say the common cases, there's a global level compression table that happens, and per ACL table, I can choose whether to include the compression or not. Okay, so now how do we discover that a given platform supports only a global compression and not a... I'm just trying to understand the workflow in this case, right? Let me, how does
if you to do that, yeah, I can actually answer that. So to do that, you would basically have the get object availability, basically say, I only support one or two tables. Of actually the number of prefix compression tables you're allowed to create. So I think through the availability API, you would have that ability to basically say that there's a limit to how many that can be created.
I still okay, Jason, that's still not clean, right? To assume that if there's one ACL table, that means it's a switch level ACL table. That might not be true, right? In some platforms, I could have just one ACL table, and that one ACL table, one compression. Some platforms could have one compression table, and they allow this one compression table to be attached to any of this given ACL tables.
Yes, so that would be allowed. If you wanted to create a single compression table and use it for all your ACLs, or all the ACLs that need compression, you might have some ACLs that don't need compression, so that can be left as null. That's allowed to be done. You can create a single compression table in that case. You can declare that you only allow creating a single compression table, and that can be done via the object availability on the compression table object. Because the compression table is a separate object, so it has a separate get object availability API that can say, here's how many I'm allowed to create. And you could, for instance, allow the user to create only one, or potentially create only two, one for SIP, one for DIP, if you wanted to go that way. And then because you're only allowed to create that many, then all the ACLs could use that one or two.
Okay, let me think once again, right? Jason, let's say I have a global ACL table, but it will still be two ACL tables because I'll have one for source compression, one for dest compression. Okay, but there are only two ACL tables possible.
Just to clarify that slightly, for the ACL table, you wouldn't have a separate ACL table for source and dest. You have an ACL. The ACL table itself would combine source and dest. The compression table could be one for source and one for dest.
Yeah. Okay. Sorry. I think I didn't say it clearly, right? In the platform, there's just a global compression tables, but the global compression tables are such that one compression table is of type source, the other compression table is of type destination. Okay. And now such table should be bound to all the ACL. Okay. So in this case, object type availability can be two, not one.
Yes.
So that workflow doesn't really work in this case, right? Whatever you said earlier.
Why does it just work? I think it.
What you said is right. You'll do a query on object availability on the object type compression table. And if we see it as 1, that means it's a switch level, there's a single compression table.
And if we see it as 2, then could we imply that it's 1 for SIP and 1 for DIP?
I'm not sure. Let's see, right? Can I query based on types? Yeah.
Actually, you could query based on types. That's a good point, because we can have that as a key type for the availability. In fact, if we don't already have that defined as a key type, that's probably a good comment.
It's not
that the type.
Okay.
Or what is resource or something? There's some flag that you can put to say
yeah, at this resource type. Yeah, that's something I should add.
Yeah, so let's actually add a comment for that on the prefix compression type field. Make that an is resource for the prefix compression type. To annotate that as resource, that would definitely help with that.
I don't understand that part, Jason. So for the type,
I'll think with you offline, not or just after the meeting. But the note can just be there that there needs to be is resource flag on this attribute.
Sure.
And then I'll just point you to how to do that.
Hey, I have a separate question. Is there going to be 2 documents or 1 document? Here in the PR, only 1 document, right?
I had 2 documents originally, one for ACL and one for prefix compression, and then I was asked to combine them together. But I can, and then Ravi asked me to add a piece about ACL in the prefix compression document, so I was going to do that. So
yeah, I agree, because the document didn't say. I mean, I couldn't find the exact usage. Yeah.
That's on my fault. When I removed the ACL document, I probably just forgot to upload the combination of the 2 documents for adding the ACL example in there. So I'll do that. I think I put the ACL example. I just did not do a documentation about it. So
I see.
Probably,
it's important to talk about the use case or usage of this compression table.
So I think I did it. I did add an ACL example, but I did not add
the attributes. They were not defined earlier.
Yeah. Yes. I need to add the attributes up here. Yes, you are correct.
Thank you.
No, I was gonna add. I did not. Ravi, you added this maybe a couple of hours ago. So I did not get a chance to update it. I will update it today.
Okay. Yeah.
And I know we have the 115 deadline is tomorrow. If we need to make changes and it's more than for the next release, it's not very critical. I was just trying to get a closure on this PR, because the longer it drags, the harder it is. So we don't just wanted to put that out there. I know.
Nader, one more thing does not come out from the document. So just from looking at the code, it's a single table which is consisting of the prefix table as well as the match on the meta, which is coming out of the prefix table, correct?
I'm sorry, can you repeat that last part? Sorry. So
I think I'm just looking at if you look at the sci-ACL.h, it has the match on the meta, right?
Yes.
As well as a prefix table, both hanging together, right?
Yes, there's an entry. Yes, there's an entry attribute that's been added, and also the ACL passing in the ACL table. I mean the prefix compression tables.
Right. So, and probably the workflow is first you do the compression and then you do the match on the meta, right?
Yes.
And the same table you cannot achieve. So you probably do compression on the ingress and match on the egress. Is that how you do it?
Compression on the ingress and match on the egress. So when you define the table, now we have the ability to define the stage of it. I added that.
Right. Yeah, I'm just saying that it's not coming out from the document clearly.
Okay.
You have how this will flow as a packet flow, right? So you define a table which is prefix table of type ingress, correct? Ingress
Yes.
stage, prefix compression table at ingress stage. And this table will be binded to a ACL table, correct?
Yes.
And that ACL table will also be of type ingress?
Yes, it should be. I mean,
right?
Now since you're defining a stage, yes, it will have to be type
And
ingress.
then after that, this prefix lookup will result into a metadata, correct?
Yes.
And that metadata is defined in the prefix table itself, but the match of that meta is now defined as an ACL entry.
Yes, that is correct. And
right?
I can add the description for it. Yes.
Yeah. But will it be still at an ingress stage or ingress stage of the ACL, or which stage it will be?
The entry will be on the ingress stage of the ACL in this case, because you're adding it on the ingress stage, right?
So is it a collapse table? Like one table consisting of both prefix table as well as the match on the meta? How will you do the lookup?
The lookup from the ACL point of view?
I mean, just from a pipeline packet flow point of view. So you have a ACL table bind to an ingress stage consisting of a prefix compression table, which is of type ingress stage. And ACL table also contains a match on metadata, which is coming out of the prefix compression table.
Yes, so
which is also at an ingress stage. So everything is at an ingress stage in the same ACL table.
Yes, so your match has to happen first on the prefix compression. Your mappings have to be done there first.
Yeah, you have a table which is contained within the ACL table, and then the result of that is also contained within the ACL table, right?
Yes.
A little convoluted from a pipeline point of view, but describe it in the document. Okay. That's what you are expecting it to be.
Sure.
Typically, I would say in that you would like to use chain ACL table, not the same ACL table, so that you have a proper packet flow, meaning that the first, within the ingress stage, first element of the chain does a lookup in the compression table, which gives you a meta, and meta is looked into the second element of the chain, which gives you the actual result. Ideally, that's the way it should be. Ravi, you were saying something?
No, I was sorry. I think no, I was just trying to say some other comment. Sorry. Go ahead. I think it's
no. But do you see the confusion?
Yes.
Sorry. I was thinking of something else. I missed this conversation. I was trying to think.
No, that's fine. I'm talking to another that we have
Jay,
to.
Jay, I think you're right. It's kind of strange. You generate it and match on it in the same stage, right? That's what you're talking about.
You cannot do that. You have to use the concept of chain elements.
I think the stage here was added as a previous review item. And I think the comment was to define which stage of ACL it applied to. So by saying that it's ingress stage, it means it's a compression table for ingress ACL. Maybe that's not ingress stage ACL. Maybe that's not clear in the description. That's the intention of that. Basically, if you're defining this as an ingress, and you're basically creating a prefix compression table for an ingress ACL.
Yeah, no, Jason, if you look at the sci ACL.h, if you can flash that, right? So here, yeah, right here, cycle. So you have this, these ones.
You're looking for the entries or the table?
That's fine. So you have these two tables, right, which are sitting in the ACL table. And then if you can, Nader, show the match, which is Boolean for the meta. You also have a match in the same ACL table for the metadata, right? And that creates a circular dependency on the same table. Yeah, this one. Right. So same ACL table consists of your compression prefix tables, as well as the result which will come out of it is also used as an entry in that ACL table. Yeah, both the things hanging there. So if you want to do a lookup, if you draw a packet flow, and I was just going through the document and that did not came out clear. I thought that was already discussed. So I was looking for an answer.
Oh, okay. I think I see. So the ACL, the selection of the table is not a result of an ACL hit. The selection of the table is just a property of the ACL table, or sorry, the selection of the prefix compression table is just a property of the ACL table itself. So it's not like you hit an ACL entry and then get the compression table. That wouldn't make sense. So as a property of the ACL table, like I'm going to do a lookup in table 5 as an example, I will use this prefix compression table. That will produce a result, and then here, what we're looking at here is where that result is consumed.
But you have an ACL table, which is a container now, right? Typically, we don't. I see what you're trying to define, but that's not how we do. Let me understand, Jason, what you're saying, right? So you have an ACL table, right? And that ACL table has another object, which is your prefix compression table. And you're saying when we do the lookup, find the ACL table, which probably, let's say, have a binding to a port or wherever.
Yep.
From there, also figure out what is your compression table object, and then do the lookup first in compression table, correct?
Yes.
You get the result, come back to the ACL table object, what you had, and now do the metadata lookup into that ACL table. It's quite convoluted. That's typically how it's not. If you draw the packet flow, you yourself will get a little bit. If you create a life of packet,
yeah, I don't see it as being convoluted. It's just there's a specific ACL compression table associated with that ACL.
with
So
that
you do
ACL
the compression
table, right?
first, and then you do the ACL lookup.
Yeah. So typically, the way we want to do is if you want to do a lookup based on output of the prefix table, then it should come first, and then the output you can still do what you're saying. So okay, let me understand again. What's the rule for deriving the prefix table? There is no rule, or
So the prefix table is, we can go up to it, but it's a property of the ACL table.
That's it. There is no rule to derive it.
All right, there's no rule. It's just a fixed property of the ACL table itself.
Yeah, it's like a object which you're deriving.
Yeah.
Yeah.
Let me see if I can find it.
Yeah, if there was some ACL rule inside that ACL table to derive it, then I would agree that would be very convoluted. But it's just a property of the ACL table itself. The ACL table can be associated with a SIP table, and it can be associated with a TIP table at the table property level. And then
right, and there is no. There has to be an ACL table entry for it too?
No, there doesn't necessarily have to be. If you want to use that result, that metadata result that's coming out of the prefix compression table, then you
right.
ACL
But
entries
for the
matching
table,
that metadata.
Table, there is no entry, right?
Right.
Yeah, we have not used it the way you are defined. Basically, you are dereferencing a prefix compression object from the ACL table object.
Yes.
That's what you're doing. Yeah, we typically don't. I think just capture it in the document. That did not stood out. It still looks little. Yeah, just capture it in the document.
Sure.
What I said, I also had the same question, but kind of I got myself convinced after what. See these things, right? 1617, 1631. These two attributes are little. That's what I think I discussed with Jason a while back. But The whole idea is, Jay, is when I create the compression table, that should come in the pipeline much before the cycle table. And in that compression table, the stage that is mentioned says that this compression table is valid for which cycle table and so on. For example, if I create an cycle table of stage ingress, does it mean it's valid for an cycle table of ingress, as well as is it valid for an cycle table of egress? Anything that happens after stage ingress, or is it only for stage ingress? That is something I am also trying to think. Today, let's say, right, I created a compression table. Jason, this is something I want to check with you. I created a compression table and I say the stage is ingress. Now, does it mean this, whatever was the compressed metadata, that can be matched only in ingress cycle tables, or can it also be done in post ingress tables? Anything after ingress, right? Ingress and
that you can do it if you want to, because you can have a ACL table of type egress and you can still match that, right? The matching is not a problem.
I just want to make sure the definition is clear. But I want to make sure definition, right? What it means here when they're defined. I think that is not coming out. So is it 1:1 or is anything after that stage?
So originally it was that we didn't have a stage. The reason we added a stage is so if you need to pre-process your, depends how you're implementing this the compression table. If you need to know in advance what is it, ingress side or egress side.
Yes, yeah.
Just in case if a vendor needs that. So if you have requirements for it to be on the ingress side, and for your pre-processing, you can still use the same table on the egress ACL. I mean, it doesn't. It just depends what you're trying to do with it, right? The stage was added for the pre-processing of the, of the table, not for ACL
instead
specifically.
Of waiting for the
right?
bind, got it. Yes, that makes sense. Instead of waiting for a compression table to be bound to an ACL table, if you have this information during compression table creation itself, helps the hardware, helps us in programming the hardware. So that is good. And what you're saying is, just like Jay said, if I create a compression table as ingress, I'll create it in the ingress stage, and depending on the device, it can apply for both ingress tables and the egress tables.
Yes, that it could apply. I mean, if depends on your pipe, it depends on your, as a vendor, your pipeline. If you can't apply to the egress, then you might have to create an egress table, do your pre-processing then, and then apply to the egress table. And the two tables might have to be the same, but
same,
same
identical if you want to have two different tables. Got it. All this becomes a little complex for the capability to be exposed. How would a NOS understand this capability, right? That is what is complex. But maybe that we can take it as a supplement because we are running short of time. Those things,
so,
right?
Right, I think in a more simplistic way, the way this PR is structured, and this is for Jason and Nader for you guys. So what you have done, you have created a binding of the compression table with an ACL table. ACL table have stages, and I know that how hardware is typically structured. So what can happen as per this PR, you can have one compression table, which is attached to ACL table stage ingress. There is another ACL table, which is, ingress. I think there are 3 stages we have introduced, right? So you can have 3 such ACL tables within the ingress stage, and each one can have its own compression table, which is very scalable, but I don't think that's what your intent is. You see what I'm saying?
So the original intent was to make the tables without a stage, so you could decide how you want to use them. But since I understand why we needed to have the stages, so now you have the stages, so it will have to come based on how you want to design it, right? In terms of mapping your ingress.
Right. Yes. No, stage is okay, but since you are dereferencing the compression table from the ACL table, right? ACL table themselves have stage. You agree with that, right?
Yes.
Right, and there is not one stage. So potentially you can create, I'm just going to the ACL stages. It's in the site types, I think.
Yes.
Let me just open that.
I think there's a pre-ingress, ingress, egress for
Right,
sure.
right. Exactly, right? So you can have a compression table which is now at a pre-ingress, ingress, and there is another one which was introduced.
Egress, probably.
No, it's on ingress stage, it's around post ingress or something like that.
Okay.
So as per your PR, since you are dereferencing the compression table from the ACL table, you can have within the ingress pipelines, actually, you can have 3 such compression tables as per this PR.
Yes. If you need to. If you don't need to, you can have, yes,
Correct.
you can.
Correct. I'm just saying that the way this PR can be interpreted.
Yes, that is correct.
Right? Ravi, you understand that, right? You can have a very sophisticated hardware now.
Okay.
We don't envision
No,
that
I
would
don't
actually go support compression in 4 different stages, but
but PR interpretation, I think we clarify. See, this is a fairly complex feature, and the way we have structured is, I still feel it's not very clean, right? If I look just at from a hardware point of view, the packet comes in on a port. First thing it does goes through the compression. After that, you get the data, goes through the ACL lookup, finds your forwarding information, goes out, right? Now we have tied the compression table and ACL at the hip, which I am not liking it, but I don't want to, create a major churn. So best is you describe in the document clearly, this is what it is, right? And this does not come out clearly from the document. That compression table is just a dereference from the ACL table, may result in so many ACL compression tables at different stages. That's not the goal of this PR, right? And then the meta, which is coming, and yeah, it's not a circular lookup, right? You just do a dereference. So first lookup happens on the compression. Then the result which is coming out is used as a match again in the same ACL table from where the compression table was dereferenced. That's very key. It's very confusing otherwise. Sure. I think this this just capture the life of packet kind of a thing. Ravi, are you okay with that? I'm okay with this PR, by the way.
Actually, for me also it's okay, Jay, but I also agree with the point, right? There's too many, I am still wrapping my head around this point where I have a compression table and an ACL table pointing to a compression table, right? I think that is what I was thinking. But Jason was saying the common use cases he sees is each ACL will have its own set of compression entries. So that's the reason I think this proposal, what Jason can...
I mean, I don't want to change PR, but Jason and others, I know how hardware is structured. You can have let's say that you have a compression table object, and same object can point to all the ports. So you have a shared compression table for all the ports. Whatever is the result coming out is the meta, which you just feed it into the ACL table. That's much simpler if you think about it.
Yeah, where you run into a little bit of difficulty with that approach, though, is that it's more complex in a single table to deal with overlapping prefixes. Because an ACL, for example, might want to have one entry that matches on prefix A and another entry that matches on prefix B, which is, for example, a subset of prefix A within the ACL table. And the prefix lookup is only going to generate one result from the prefix table. And so it needs to encode in that result if it needs to handle that use case. The fact that there's, that more specific entry is really matching two different things. And that can be done with the bin code, how you handle the bin code encoding. Now, with a single prefix table per ACL, it's fairly easy to solve that. You can do things like, constrain the user to prevent them from doing, overlapping prefixes in the ACL. You can, come up with...
Really not. I mean, I don't agree with that, Jason. All you're doing is a dereferencing of a compression table. There is no binding in the entries into the compression table and ACL table. There is no such constraint you have put in your PR. All you're doing is just a deriving a compression table object from an ACL table object. That's all you're doing.
Right, but I think the suggestion we're making is that you should have a scenario where you have a global prefix compression table that all ACLs must share. And that I don't think works well. If you have multiple ACLs trying to do compression, forcing them to share the same table, without some metadata from like which ACL you're going to look up in as part of that lookup, that could be difficult to design that, to basically to program that single compression table, because you're kind of merging things from multiple ACLs into one.
So let me understand. So, and sorry, I got my brain got warped on that, packet path. So you're saying you can have multiple compression tables, each one associated with separate ACL table, correct?
Mm-hmm. Yes.
Right. And typically today we do the ACL table selection based on whatever that binding is of the ACL table or the ACL group, correct?
Yes, and that could be a switch binding or a port binding. Switch binding is easy, so maybe we'll talk about port binding.
Port binding, right? So you are saying in that case, it gives you ability to select different compression table for a given port. Is that the argument?
Yes, given different compression table per port, but not independently mix and match with the ACL being used, like that ACL.
Right.
Yeah.
Yeah, but if you, I understand. So let's say that you have a ACL table 1, port 1, ACL table 2, port 2. And in that you want to have a different compression table, let's say compression table 1, compression table 2. So port 1, compression table 1, bind it to ACL table 1, and so forth, right? That's what you are achieving.
Yes.
But my argument is that you can have same thing and have the compression table 1 binding to port 1, compression table 2 binding to port 2. You really don't have, and that kind of is a natural flow of the packet, comes in on the port, resolves the port, derives the next stage of information, is the compression table 1, finds the metadata, goes in the associated ACL table, which is table 1, does a lookup in the metadata. That's a more natural, flow of the packet. And I'm sorry, I don't want to, do bigger churn in the PR, but I don't see why you cannot achieve what you are trying to achieve by using this. We are not saying you need to have one global compression table. You have multiple compression table of type ingress or egress binding to port. And whatever is the metadata coming out, right, that lookup, you can introduce a new attribute for a compression meta into the ACL entry, which you already have.
Yeah, Jay, you're right. However, doing so basically consumes some port level attributes, right? Because you've offered the ability, you've basically offered a flexibility to the user. The flexibility you offer now to the user is the ability to kind of mix and match which compression tables get used with which ACL. You've offered them that flexibility by saying, okay, there's a separate port attribute or something in the port ACL list that says, here's the compression table to use.
Sorry, yes, I don't agree with that. I haven't changed anything. It is same thing. All I have done is change the pointer. So today you have a proposal, which is ACL table 1 contains a compression table, right? Now that ACL table needs to have a binding, and it's binding to a port 1. So today, what your proposal is, port 1, P1 has a binding to ACL table T1, which comprises of a compression table 1. That's your flow.
Yes, and imagine an implementation in the pipeline where you have a small table that maps ACL tables to the compression table to use. Okay, so you basically get your ACL table out of the port properties. You then map it to the compression table to use for a small table, and then you go to your actual real compression lookup, and then your ACL lookup, and so forth. So imagine that.
Correct.
Now, if you move that property of which compression table to use over to the port, now you need you need to put that in the high scale port properties table. Now, an implementation that wants to put it in the port properties table, maybe they don't have that small table, could flatten it. Like you see, okay, every time you use this ACL, I put the compression table also in the port properties, and I can know which one to do. So an implementation could flatten it that way, but it's hard to recover for the other implementation I described from the flattened version to the non-flattened version, if that makes sense.
Right. No, so, see, but what you are described, and that's how I was thinking, that's why I know the hardware implementations, right? So that's why I was steering towards the chain concept. Let me describe what you described. Let me just rephrase it so that we are on a baseline. And it's very important. So you're saying that when a packet comes on a port, you go through some resolution for a compression table selection, correct? Once the compression table selection is done, then we do a lookup in that compression table, and then the metadata is looked into the ACL table. Correct? Is that correct?
Yes, that's correct. And the key will be how that resolution is done.
That's how it will work, right? And you're saying if I do the direct binding of compression table with the port, that intermediate optimization which we have, where we do the compression table resolution based on some rules, that path, that optimization is gone. And I agree with you. But that optimization is not captured in this proposal anyways. If it's not captured, then it's not there. I exactly know what you're saying, Jason, but in the PR, for whatever reasons, we have hidden that step. We are not exposing that step.
Right, but I think that isn't that implicit from like how the attributes are defined, that it's, this is a property of the ACL table, therefore kind of the natural implementation would be to, or the most obvious implementation would be to take the ACL table, get your compression table, go look up in your compression table and do the optimized path. And then if an implementation is, well, I can't do the optimized path, I'll just flatten it. And then, that would be an implementation decision.
I would have agreed with your statement if your compression table resolution is happening based on some rules from the ACL table. You said it's just a dereferencing.
Yes, so you are dereferencing or a mapping. You can think of it as a mapping of the ACL table to the compression.
I mean, in a hardware, there cannot be mapping. You have to take it as a dereferencing and plop it in the middle somewhere, right? And we have not defined, when you plop that compression table before ACL table, what's the rules for resolution of those ACL compression tables? That rule is kind of hidden, that does not exist. So today you have the workflow or the packet flow where ACL table is resolved for a given port. From that ACL table, you derive the compression table and you do a lookup in that without any rules,
Yeah. The way I would think of it is like if I were writing psi.p4, I would say, okay, the port provided the ACL table. Now there's another table, map ACL table to compression table. Then the next table, use compression table, look up in that compression table to produce the compression result. Now go look up in the ACL table. So think of it as like a mapping.
Yeah. So if you agree with that, then my reasoning is then that's convoluted. Take out the compression table from the ACL table. You have port which has a binding of an ACL table plus same compression table. You still have the exact same binding. You get the same result. But I do know your implementation, what you're talking, that becomes difficult. But the way current PR, today we can agree. So tomorrow somebody will come and say that if you are just dereferencing your compression table from ACL table, it's not a right place, right? Your port is already pointing to ACL table. Just let it point to compression table also. It's very convoluted.
That forces the unoptimized implementation, though. I think if you do it that way.
But we don't worry about implementation, right? So that's the abstraction. So either you abstract that stage where you are talking about the compression table selection and expose it, right? I mean, implementation, we hide it by using the abstractions. That abstraction is not present in the current proposal. I just want you to understand that there is a little bit of a, there is a little bit of a uncleanliness in this even now. How do you want to, how do you propose to make forward progress?
So I think there's a couple things that are open. One is, I don't know if we came to a conclusion on the early item we discussed, which is whether the priority is needed. I think
that we agreed it's not needed. That I don't see it's needed. No.
Yeah, and the other one is the config model that we just discussed here. So the config model, I'm still not convinced that I'm just saying, like, if you're doing multiple ACL tables, each with their own compression table per packet, like flattening that all out onto the port or forcing that all to be flattened out onto the port.
No, you don't flatten it out, right? In your current proposal, you don't.
Right. In the current proposal, we don't. But in a proposal where it's a port property, you've done that.
No, that's because you're looking at implementation. If you just look from a PR point of view, you have the same compression table, which is right now sitting with the ACL table. See, port can have only one ACL table, cannot have multiple ACL tables, right?
Mm-hmm.
So
I mean, you can have multiple, but yeah.
Then you have to go through the group and all that stuff. Yeah, right. It can have, but in the way we are looking at it, so you have the same compression table, which instead of having a relationship with the ACL table, now has a relationship with a port. And different compression table will have a different relationship with different port because there's a different ACL table sitting there. So we are not collapsing from a PR point of view. How you do it in the hardware, you lose a resolution. So tell me one thing. Okay, let me ask differently. So even though you are deriving it from ACL table, won't your hardware need some rule to derive the compression table? When the packet comes in from the port, what's your rule to derive the compression table?
So the rule is just a simple mapping of the ACL table to the prefix compression table. So you could think of it as an ACL table has some properties that are table properties, and one of those properties is this is the prefix compression table to use for that ACL table. Another property might be, and that's why the PR is structured this way.
No, in hardware. How you reflect that in hardware?
Even in hardware. No.
I mean, how? So in hardware, if your ACL table comes first, from there you resolve the compression table, or the compression table comes first and from there you resolve the compression table and the ACL table?
So you get the hardware table ID. Okay. So there's going to be some ID or label or basically what is the table that you're looking up on, you're looking up.
Where did you got that? No, where did you got that table ID from?
That would have come from the port. That would come from the port.
That would come from the port, right? So that's your compression table ID.
That's not necessarily the compression table. Multiple ACL tables can share a compression table. It's allowed.
Okay.
Multiple ACL tables could share a compression table. They're not required to, but they could. So there's kind of an n-to-1 there. So you can't just go prefix compression table and then get the ACL table from the prefix compression table. That reverse direction doesn't work. So you get the ACL table. Now you map that ACL table ID also to a prefix compression table ID because you could have that n-to-1. You could, for instance, have a global compression table and multiple ACL tables. So we allow that.
Right. So sorry, Jason, just go slow. So how do you find the compression table from the ACL table? There is just the hardware that's just dereferencing.
Yeah, just you could think of it as a small table lookup of ACL ID to compression table ID.
I see. Okay. I think, can you capture that packet? I see that packet flow working, by the way, right? Can you capture that in the document, if you don't mind?
Yes, I'll make sure it's captured.
Yeah. So that somebody picks up, then they know how the typical hardware mapping can be done, right? Yeah, that's fine. I think I can see how that's working. Yeah.
Now it's possible for an implementation to choose something different, right? It can choose to, I don't have that extra table. I'm just going to burn some more port properties and code the compression table to use also on the port, which I think is what you're describing. And maybe there's more resources over there. And now every ACL or every port that's using that ACL also has some data that says, okay, here's the prefix compression table to use.
Right.
You can do that. But now
No, I
that
got
might
it.
be a more precious resource in the
Yeah, Jason, I got it. You basically have an intermediate table, which is nothing but a ACL table ID lookup. From there, you get the compression table ID.
Yeah, and that table is used for, I mean, that's not the only property that we get about the ACL table, but yeah.
That's you don't want to give out too much IP that's you're using, and that's good enough, right? But if you capture that, then it gives a pipeline flow. That's how the packet flow is going to look like. And I think that's why we earlier talked about pipeline. This does have an implication on pipeline. I don't think we modified the pipeline, right?
No, like in terms of what?
In terms of like the see what we are doing, just the, which is fine. You can capture in a document the way compression table is getting resolved through the ACL table ID, which is another resolution in front. The dereferencing is done in the hardware. And since the compression table is sitting with the ACL table, naturally in the pipeline, they will sit next to each other. You got another
Yes.
what I'm saying, right?
Yes, and I'll add the I'll improve that part of the documentation for the packet flow. And if there's issues with it, we can, I can expand on it, or if something doesn't make sense, we can also.
Yeah, you can send it offline to me as well if you want, and I can review.
Sure.
Yeah.
Thank you.
I think that's good enough. I had a hardware FRR PR. Do you want to go ahead and quickly take a look? Tejaswini, I think, is gone on other meeting.
No, I'm here. Yeah, I mean, if
I had
what
one
do you
more.
need for sign off on that?
Sorry.
Jay, question for you. Is that something we need for 1.15?
Yeah, we have likes of you waiting for us.
Okay. Is that PR almost done, or
it was reviewed multiple times? I think
right.
the document was not added. I added the document.
Okay.
It's
if you want to go ahead and discuss, and you think we can close it here, like we only have a few folks here, but if we can close it here, yeah, please go ahead.
I think we have Jason and Ravi and Rita. Ashutosh had questions which I already resolved. Let me just quickly go and see if we can close. If it becomes a bigger discussion or things, then we'll come back.
Yeah, I had some comments on it, but I think your answer resolved those to my satisfaction, so I'm happy.
Yeah, let me just add, I added this document. This might help. So actually, it's really a very, very simple PR. So this one I added what is the current workflow for software FRR. So here today, what we see, we create the next top group type protection today. And the moment we do a next top group type protection, there are two fields which become active because they are controlled by the condition flag, which is the primary and the secondary, right? So we configure the role primary, that these are the, next stops, which are primary, okay? Then we also do, there is a monitoring attribute, and it software monitors that monitoring attribute, which can be a next stop, port, etc. And if there is any failure, then it's within this next stop group, which is of type protection, software sets the switchover flag. And the moment this sets a switchover flag, there is a secondary configuration which takes effect. So what all we are doing is, in hardware, still everything is same. You have a protection group, which is of type protection. Okay. You have primary, right? Primary set. The secondary set, which you will, as a backup, which you will configure, now it has another type. And the type is given to that as a hardware protection. And the reason you need that, because when that next stop group or next stop members are created in the hardware has nobody setting that next stop group. Hardware has to know that this is actually a group which is protecting these set of primaries. So when that, and group creation can happen in any order, right? So that's the reason why we need a new type. So hardware-based trigger. So in this case, basically what we do, a new next hop group type protection is created. Okay. And all the workflow remains same. So just let's go to the workflow. So in this case, this is the example. You have a leaf and spine. There are two uplinks. Both the uplinks, are primary, and they are protected by a next hop group, which is another next hop group of type hardware protection. And if you see, I'm pointing the same uplinks to them again, right? And that's a valid configuration. I've taken this as an example. Now, why you will do that? There's for redundancy, because hardware can, let's say that there's a failure between NH1 and NH2. Secondary will take in, because it's hardware protected, it know that which one is gone down. It will just pick the right one. You can have even ARS enabled on it, right? So you can create all existing mechanism, everything remains valid, but I have not gone in that detail. So workflow looks like you create a type protection. You create another next hop group, which is of type hardware protection. And the moment hardware sees that this is actually going to be backing up, it allocates from a resource which is capable of backing up the primary next hop. We create, standard next hop group, next hops, create the primary entry with a configured role as primary, right? Primary, I think this is typo because NH2 has to be secondary. I'll fix it. Program the secondary next hop group, right? And this you see NH. And that's it, nothing else. That's the PR.
Jay, can you explain the difference, right? What is the difference between the next hop group members? What's the difference between the primary next hop one, primaries next hop one and next hop two are added as next hop group members twice. Once for primary and once for secondary.
Don't take that example. You can just this for convenience. You can make it 3 and 4.
Okay, so now let's say NH1, 2, 3, and 4, right? Of which will be primary and which will be secondary?
Yeah, let me fix it. So this is what I was doing. So let's say NH2. This was one convoluted example, which 4, 3. Okay. So now you create a primary, right? So this is the NH1. You create a next hop group. One is a primary. This is just a different. You create a next hop group 2, which is of hardware protection.
Hardware protection. Okay.
Right. This is going to protect the NH1.
Correct. Now the members configured role, right? How does it change?
So members today you configured
role.
Right. These are the members, next hop, ref, etc. And then you create next hop group member. So this is role primary. Okay. This is for NH group member 1. Okay. This is for group member 2. Let's just 1 second. Let me
both are primary.
Yeah, both are primary. Right. Now we create secondary. Okay. The secondary. And this will be NH3, NH4, role secondary. Role secondary. That's it.
Jay, line by 140 should be NHG2, I guess. 140.
NH
140.
G
140.
Let's take a member NHG1, NHG2. There we go. 3, 4.
Jay, there's only 2 next hop groups, right? There are 2 next hop groups and 4 next hop IDs.
Sorry. Right. Yeah. No, sorry, you're right. You're right. 2. And where is the next hop ID? Next hop
This should be 4. This is 4. The first one, this should be 2.
There should be 2, 3, 3.
Next top group 2. I think first is the group, second is the next top.
That is the true, that's correct. And the ID, this is 3.
3. And so what you're saying is secondary. Sorry, I don't really know the normal workflow, software FRR workflow. So I'm trying to understand this part.
Yeah, software workflow. I think I have.
Forward.
Let me show you. This is the software workflow. Right, so you create next top group. You create members, primary or secondary. Right? And secondary will be another next top group or next top itself. Right, since its primary is active, then there is something called as a monitored object within that next top group. Right, there's another attribute. This attribute is basically monitored by, this says that what all state of the object's NOS is monitoring. It could be next top, lag, port, etc. Right, and once there is a failure on that object, then software comes, and for this next top group, it sets the set switchover.
So
okay. So there's a software
so
intervention.
Software intervention. And what you're saying, 1 second, let me try to understand. So here I could have one or more primary members and one or more secondary members. Once the monitored object will be associated for each of this, all the member. Each member will have its own monitored object. And software will set, sorry, each in this example, right, Jay, member 1, member 2, each of them will have their own
monitored object.
Monitored object. Okay. So, and the intention is the software will go and set the monitored object anytime. It will keep setting the monitored object, and the hardware will automatically, when the hardware figures out that all the primary members are inactive, it will start picking up the members from the secondary. Is that the...
No, not all. So two things happen in the hardware. See, this monitoring, software is doing it, right? Software does not do it, hardware do it.
That's a new difference in your new proposal, correct?
And that's something implied. You don't have to do anything, right? We just don't need to set this. The other thing which also hardware does is also this implicit setting of set switchover is done by hardware now. This block is completely taken over by the hardware.
Okay, Jay. So, sorry, just to understand, these blue things are not there today in software-based IPFRR. This new
today, blue things are there. This is all there, right? This is how today it works in IPFRR. This is software-based.
Okay.
Okay. If you understand,
somebody monitors and
so no, I'm saying that this is software. This is what we have today. There is a NOS monitoring, and monitoring event will trigger setting, and set means then the inactive, whatever the backup was, becomes active. So in this case, the secondary is backing up one or more primary.
Okay.
Right.
So per next hop group, we have a set switchover, and that will
Correct. Yeah, it's per next hop group, exactly. Right. And same thing is true with hardware, except this setting is done by the hardware. There is no software intervention, and monitoring is also done by the hardware. So this control loop, which was including the software, right? This control loop of blue is completely gone away. So if you look at hardware-based FRR, there is no setting done. This monitoring is done by hardware, right? So we don't have to set this attribute. This hardware takes care of it. The only thing is hardware need to know who is backing what. So that's why we needed this new type. So hardware knows that this is the next hop group, which is backing this next hop group, these members. So anytime this failure is, this protection group will take over the function.
Protection.
Yeah.
Protection.
So, yeah. So from PR point of view, all we have done is introduced a new type here and introduced some error counters. So,
so you want, okay.
Yeah. So if you see in the, I'll go in the, so this is 2 counters that how many times, how many times, switchover event happened for a given port on which the packet was coming in. And when the, the switchover happens, the previous port may have some remnant packets in the queue, they will get dropped, and how many such drops were experienced.
Okay, Jason. Okay.
Right. So if you see, and this is, so this is only one change. That's it, nothing else. And this PR has only, three lines of changes. Yeah, it's not a very complicated and
it's it looks simple, but only thing I need to go verify the software IPFR. I'm unaware of that, right? So I'll just
that you can look. If you want, I can upload this slide, put it this as well into the this explains how it's done.
Okay, that could help. There's no IP, right?
Yeah, I'll put this slide deck also, check it in.
Okay, Jay. I'll try to take a look at it, Jay. If I'm fully convinced, right, I'll also upload. I'm just reading it. I'll try to review and upload. Yeah.
Correct. Yeah. Okay. Anything, Jason? Okay. I think Jason dropped. Nader, if you can get hold of Jason and see if he has any questions on it.
Sure, I'll do that.
Okay. All right. Thanks to Jaswini, and thanks everybody for.
Yeah. Thanks. So Ravi, if you could close on this one, like review this and finish it before end of tomorrow, that would be good. End of
Tuesday your time, right? Yeah. Jason, Jay, please load.
I did already. I already asked, and I think looks like we have done some hard coding. I already asked on the chat, the team, that how you're resolving. So most probably what you are proposing will look good, but I will update with my observations, right? What we are done. Yeah. But most
Jay,
probably
what I was talking was, thanks. Thanks, Jay. For this hardware-based FRR, if you can load that, upload that software FRR spec, right? I'll take a look at it tomorrow morning, my time. By your daytime, it should be.
The software FRR spec is already there. If you can look into the.
Maybe if you can, sorry, let me search then, right? If
it's there. Let me show it to
documentation code.
The SIP IP FRR like that. It should be there. SIP proposal.
Yeah, SIP proposal FRR.md. Okay.
Yeah.
Yeah, I found it. Let me take a look at it. Yeah, thanks.
Yeah. So that slide is just a summary of this one.
Oh, then thanks. Let me take a look at that. Yeah.
Right. Okay. All right. Okay. Thanks.
Thanks
everybody. All right.
Thanks, everyone.
Thanks. Bye. Thanks, Jason. Yeah. Bye.